students, today we will discuss about vector. So you know the physical quantities are of two types, scalar quantity and vector quantity. Scalar quantities are those quantities which are having only magnitude for their complete representation, whereas the vector quantities are those quantities which are having both magnitude and direction. So a vector can be represented by any English alphabet. So suppose I am writing A is a vector. So it is represented by an English alphabet putting an arrow on it. It has two parts. One is magnitude, another one is direction. So magnitude is written by this mod and the direction is written by a cap. So this is known as your magnitude part, and the unit vector or the cap, this is your direction part, right? This is your direction. So this is the basic representation of a vector. So any vector can also be represented graphically. So graphically, how we represent the thing? Now that we use a coordinate system. We use a coordinate system. So this is known as your graphical representation. So in the graphical representation, we have a quadratic, that is coordinate system. And in this coordinate system, the normal way of representation is this one will be your north direction, this one will be your south, and right side will be your east, left side will be your west, right? So if I write a vector that is 2 meter along north, 2 meter along north. So how I can draw this one? This one I can draw. You see 2 meter along north. So what is the north direction? This one. So 2 meter. So I have to take the approximation for 2 meter. So this vector, suppose A vector. So I can write this A vector and its magnitude is 2 unit, right? Its magnitude is 2 units, right? So this is the way how we represent the vectors in graphical method. Suppose another example I will take. Suppose I will write 1 meter along southwest direction, southwest. So now you see we have to consider the quadrant, southwest. So what will be the southwest direction? This is south, this is west. So angle is not given, so that will be in between the southwest quadrant. So this will be 45 degree. Either it may make with the y-axis or with the x-axis. So this is 45 degree angle, right? And here the magnitude is 1 unit. So here I can represent this one. Comparatively this is 2. So this will be your 1, right? So this I will write this one as a B vector. So B vector, its magnitude is 1 unit, right? So this is the type of representation. Similarly, if I talk about a third vector, suppose I am considering this vector as, suppose you take 3 meter along, suppose 30 degree east of north, east of north. So how to represent this? So you see here 3 meter along 30 degree east of north. So east of north. So that means we'll start from the north side 30 degree towards east. So the direction will be like this. Understood? So this is 30 degree. So 30 degree it is making east of north. Now 3 meter. So comparatively if you see this is 2 meter, so this will be 3 meter. So I can write this one as a C vector and this is 3 units. So these are the different way how we can represent a vector. So you know the magnitude of the vector is represented by the comparative length of the line, and the direction is given by putting the arrow on it. So this is how we represent a vector in graphical representation. I think that is clear to you. So any vector that is having magnitude and direction. So suppose I write here, suppose I write one vector that is B is equal to, suppose I am writing this one as B is equal to 5 and I write suppose I can. So what it means? It means that B has a magnitude of 5 units. So B has a magnitude of 5 units and this I can means this is known as a orthogonal vector. Orthogonal unit vector. So orthogonal unit vector means its magnitude is 1. It will represent only direction. So what will be the direction? Now you see here we have three types of representation along x-axis, y-axis and z-axis. So the normal way of representation is along x-axis we write this one as I cap, along y-axis we write this one as j cap and along z we write this one as k cap. Right? So suppose I write V is equal to 5 I cap. So that means the magnitude of V is here 5 units and the direction will be along positive x-axis. Along positive x-axis. Understood? So similarly, we will take another example. Suppose you see here, suppose I am writing here another vector. Suppose I am writing here R1. R1 is a vector. And suppose I write this one is here 5j. Suppose 5j. So what we understand here? I am understanding that the magnitude of this vector is here 5 units. That means the magnitude of this vector R1 will be here 5 units. And what will be the direction? This is j cap. J cap means the direction is along positive y-axis. Along positive y-axis. Right? So this is how I can represent a vector quantity. Another example I will take. Suppose here you see, suppose I am taking another example. Suppose I am written here R2. So suppose I am writing R2 is equal to 6. Suppose minus 6 kk. Minus 6 kk. So what we understand here? Here the magnitude of this vector will be 6 units. So here I can write the magnitude of this R2. This will be your 6 units, right? And what will be its direction? Its direction will be along k. Minus means opposite. So k is your positive z axis and minus means that is negative to positive, that is k. So here I write along negative z axis. Along negative z axis. Understood? So this is how we represent a vector. Another purpose is there, that is analytical representation of a vector. So any vector will be having three components. That is the component along x-axis, along y-axis or along z-axis. So I will take an example having two components. So the general I can write here. Suppose you see, suppose I write another vector r is equal to x I cap plus y j cap plus z cap. So what it means? It means the vector is at a distance of x from x-axis, at a distance of y from the origin along the y-axis, and along the z-axis the magnitude is your z, right? So this vector will be somewhere here, right? So this is the point. I write this one as x, y, z. So the coordinates of a point can be represented graphically in terms of a vector, and I can write this one as the components of x I k plus y j k plus z k. I will take another example. Suppose one vector is given here. Suppose it is given 3 I cap plus 4 j cap. So how to represent, right? So we have to draw a coordinate system. Here 3 I cap means from the origin we have 3 units, and 4 j cap means along the y-axis this will be the 4. So you see here like a coordinate system. Here this is the point, and this point is known as, in terms of coordinate system, this will be 3, 4, and if I write the vector, then this will be from the origin. So this vector is here r, right? So this is the way to represent in terms of its components. So if we are having two components, then this is known as your rectangular components of a vector. If we are having two components, then this is known as your rectangular components of a vector, right? Rectangular components of a vector. So here, if this type of arrangement is there, I can say here the magnitude will be, the components ka square, that is x square plus y square, and this will be square root. And the direction I want to find out, then any vector, this is the magnitude and the direction. So what will be the direction? That is the unit vector, that is vector by the magnitude. So by using this formula, mathematically I can find out r vector is your 3 I cap plus 4j cap, and this one will be equal to your 3 square plus 4 square, so that is 9 plus 16, 25. So this will be your fine, right? So this will be your fine. So this is your unit vector. So in this way you can understand if any type of representation is there for a vector. So suppose someone is asking me what will be the direction, so I have to mention here the theta. So you see here what will be the theta. So this is the vertical component, so this is your y component, and this is your horizontal, this is your x component. So if I consider this right angle triangle, right? So in right angle triangle OAB, I can say here tan theta is equal to, what is tan theta? Tan theta is equal to perpendicular by hypotenuse. So this is P by B. So here I can write this one as y by x, right? So this is your tan theta. So for direction purpose, I can write theta is equal to your tan inverse y upon x. So if I want to find out the direction of this vector, particular vector, so this theta will be equal to your tan inverse, that is y upon x. Y upon this is your 4 upon 3, so that is 1.33, right? That it will come. So tan inverse 1 point, so that will come approximately 56 degree or 57 degree like that. So here I can say this theta will be 57 degree, right? So analytically I can write this vector r is equal to 3 I cap plus 4 j cap, or direction wise I can write, now this vector is having a magnitude of 5 units along 57 degree with the positive x-axis, So I think now it is clear to you basically what is a vector, what is its magnitude, and what is your direction, and how I can represent this vector graphically, and what do you understand by the rectangular components of a vector. Thank you.